Okay, guys, let me know if you guys can hear me well. Let me know if you guys can see me well. If you could, put something in the box. You guys can type something in there that I look good, I sound good, and then we can go ahead and get started. Okay, guys, very good. Okay, so let's go ahead and get started. So, for those of you guys that are joining us, thank you guys for joining me. Now tonight, just like we did last time, guys, I'm gonna be covering your questions. So you guys, if you have any questions about the CISSP exam, go ahead, put it in the box. I'll make sure that I get it answered for you guys. Any comments or anything like that. So what I want to do tonight with you guys is we're going to be reviewing one very important topic for your exam, and that is going to be the SDLC, or the Software Development Lifecycle, which is a topic that every single one of you will see on your tests. I mean, I get a lot of feedback from students that has taken our class and taken the exam, and almost every single one of them gets questions on Software Development Lifecycle, or the SDLC. So today I thought I said last week we'll cover this topic this week, and I'll give you guys a good overview of what it looks like. What is it that you need to know from it? What are the phases of it? What you should know, what's happening in those particular phases, and basically all the things you need to know for your test about it, and what type of questions you get. So I got about 8 practice questions I want to go over with you guys when we're done with this. So let's go ahead and get started with this. So the first thing I'm going to do is I'm going to ask you guys if you have any questions that you guys would like for me to answer, just go ahead and type it in the questions box. All right, so just type the questions in the question box. If you guys don't have any questions, go ahead and just relax, and then I'll get to my question. I do have a question for you guys. I see some of you guys says here that you have scheduled your exam for March 1st, March 4th. Another person says March 30th. Let me ask you guys a question. The rest of you guys, have you guys scheduled your test? If you have scheduled your test, put the date in the box. Now, I'm telling you guys, if you have not scheduled your exam, it's hard to get an exam date. It really is hard to get an exam date. Now, I mentioned last week that ISC Square is going to open up the ability to do online testing. They're doing that pilot online testing. I forgot the date. Did they start? I think they opened that today or something like that. I gave you guys a link on that last week. So put the date in the box. Let me see what date that you guys have scheduled for your exam. So, all right, so I know I got a couple of you guys on March 4th, March 30th. So that means that date's approaching quick, especially like March 4th, right? If you're doing March 4th, that date is going to come and go very quickly. So make sure you guys do all your studying. If you took my class, you know what you have to study. Trevor is taking it February 23rd. So that's really close, right? So hopefully, Trevor, you had studied well. Hopefully you did a bunch of practice questions. Hopefully you know your topics or your quote-unquote hot topics really well. If not, Trevor, it's gonna be a really hard test. All right, so I see you guys don't have much questions here tonight. Last week you guys had a lot of questions. So let's talk SDLC. And we're going to spend a few minutes talking about what is the SDLC and what is it that you need to know about it for your exam. And I'll show you guys a variety of different things that you're going to see all over the place. So let's go ahead and get into this. So what is the software development lifecycle? Now, here is the software development lifecycle and the different things that you need to know about it. So before I get into this, I do tell you guys, a couple of things you see that's all over the place is some people call it the software development lifecycle. Some people call it the system development lifecycle. Now, if you just do a quick Google search on this topic, you'll notice that it is really known as the software development lifecycle. your exam objective calls it the software development lifecycle, but it's also known as the systems development lifecycle. Oddly enough, the official study guide, the CIBEX book with Mike Chappell, he calls the system development lifecycle. The Sean Harris book and the exam objective calls it the software development lifecycle. In the end, it really doesn't matter software or systems. They're basically going to have the same thing, right? The phases are going to be the same. Now, before I get into the phases that I have here, I want to just talk to you guys about the names of these phases. Now, Mike Chappell, in his study guide, particularly said the phase names don't really matter. But unfortunately for you guys, on the exam, they're going to give you the phase name. They're going to say the testing phase or the development phase. They're going to give you actual names of phases. And you're going to have to know what's happening in each of those particular phases. So now, when he says in the study guide that the phase name don't matter, it's not that the phase name doesn't really matter. It's that there is no really such thing as a standardized SDLC, right? There's no like the phase has to have these particular name. You know, you look at some other models like the compatibility maturity model or CMMI. That thing has a very defined name per phase, or I should say per level. But in the SDLC, there's no such thing. Every author that writes a book or in fact, when I wrote my PMP study guide, I talked about the SDLC in a part of it, in the Agile portion. And the phase names, I just made them up because that's how this thing is done. So to show you guys what I mean, so if we go back here to the famous Google, and you look at the big one that's on Wikipedia, it's like initiation, development concept, planning, requirements, design, develop, test, implementation. And then if you just do an image search of SDLC, you'll notice that it's different phases. So design, implementation, testing, right? So if I go here, here's another one, requirements, analysis, design, coding, testing. Now, every time, almost every single one of these things, requirements, design, construct, test, release, implementation, almost every single one of these pictures that I'm going to click on, the phase names are probably going to change very slightly. What you need to know for your exam, because you don't know what they're going to name the phase, right? It's not like the ISE Square published a set of phases. They're like, okay, these are going to be the phases that the exam may cover. They don't do that. If you take a look at the exam objectives, it doesn't have that. All it says is software development lifecycle. It doesn't say anything else. So with that in mind, guys, let's take a look at what it is. And then we're going to go through it. We're going to talk about what you're doing in every phase of the SDLC. And we are taking a security test. And then we're going to go back and we're going to take a look at what we're doing in the security aspect of every phase. So let's go through the phases. Now, I did put in brackets over here, text, the security aspects, right? We are, at the end of the day, we're just not looking for functionality. We're looking for actual security aspects of this. Now, the one that I have here, now I am going to tell you guys where I got it from. If you have the Sean Harris study guide, that's where I got this from. Okay, so this is more related. I think the Sean Harris study guide just did an amazing job covering the SDLC. I think Mike Chappell's book is really good. He's a really good author, but I think he lacks here a little bit. But the SDLC in the Sean Harris book is the one that I taught with, that I've been teaching with for 100 years, and I believe this is the best one. According to all my students, this one here is a much more better representation of your tests than the others are. So what exactly is the SDLC? Well, software development lifecycle. The SDLC is what you're going to do from the moment you think of a piece of software all the way to actually coding it, testing it, installing it, using it, and then throwing it out. So it's from conceptual of what the hell your software is, all the way to throwing it out, to making it, using it, and throwing it out. So it's the entire quote unquote life cycle, and that's what your LC is going to stand for. It's that entire life cycle of the software. Now, most SDLCs that you're going to find on the interwebs is going to look very similar to what I have here. Now, I did add in an extra one. Most of them doesn't have this disposal. That's something that I'm going to cover later, but that's something that I know shows up once in a while on people's exams. So I'm going to say why I'm going to talk about that. So let's go through it. Now, it's not a hard thing. It's not very difficult at all. Requirements gathering. What is this phase about? This is the first thing you're going to do. Depending on certain SDLCs, they may have a phase called initiating. In that way, you're getting approval to actually do the software. But in requirements gathering is where it really starts. Requirements gathering is when you start to gather all the requirements of the software. Let's say you're making an accounting software. Let's say that software has to be, it has to do accounts payable, receivable, it has to do payroll, it has to do banking. That would be some of its requirements: to write checks, to make invoices, to pay people, to reconcile bank accounts. That would all come in requirements gathering. The next thing now is designing. So when you have come up with the actual software itself, when you have said, okay, these are the requirements that we're going to have, the next thing you have to do is to design that software. You have to say to yourself, okay, so these are the requirements. They want the accounts payable, they want the receivable. Now all of the designers comes together. And what they do, designing a software is really about determining the table structure, the logical data models. A logical data model is nothing more than how the tables in the database would be laid out, what field they're going to have, how the tables are going to be related. They're going to determine, hey, this is how we're going to code this thing. These are the languages we're going to use. Once they have finished deciding how to build the software that's in development, then they're going to test it. Then they're going to develop the software. So they design it, then they're going to develop it. Developing is what? Coding it. Once they code it, then they're going to test it. So testing has a lot of things here. Once the coders are finished actually coding the software, then they're going to go ahead and testers has to come in and do those user acceptance testing. They might do all different types of what's known as the dynamic tests. Then they're going to release the software. This one here, they're going to install it to the actual users' computers. Now, this is where they're going to be doing all the updates of the software. And then eventually the software is no longer valid and your company has to get rid of it. And when your company has to get rid of it, disposal of the software. In the Wikipedia article, this is called disposition of the software. Disposal of the software is when they throw it out. Now, in the military, this is a big thing because in this one, you have to sanitize all the media. We'll come to this in a few minutes. So this is the standard gist of the SDLC. Gather your requirements, design your software, code it, or develop your software. So on the development, we could say code it. Test the software once you're done. Release the software or install it to the user base. And then you use it for years on end. And when you're done, you have to dispose of it. So this is just the functionality of the SDLC. Now, what I'm looking at is security, right? We need to know the high-level overview of what you're doing in those phases. But realistically, we need to know the security aspect of it. And this brings me to a term that I want to talk about that has been known to show up on people's exam. So this is the SDLC, but I want to talk about a term that you may hear about. And this is called the SSDLC. This is not a term you're going to really find in your book, or at least I can't remember reading it in any pretty much of the study guides, but it is a term that students have told me that have showed up once or twice on people's exam. So I want to talk about this. So we have the SDLC, and then comes the SSDLC, or the Secure Software Development Lifecycle. As you can imagine, you're taking a security exam, you probably want to know this one. Now, keep in mind, this is not I had a good link on this thing here. Nope, not this one. Keep in mind that it is not a different SDLC. It's the same SDLC. It involves more integrated security testing and more security in every phase of the SDLC. So I'm going to share a link here with you guys just for you guys to review it. So, but this may or may not show up on your exam, the term of itself, SSDLC, but I do want you guys to understand that there is such a thing. So if you do see it on your test, you're like, what the hell is that? Yeah, it does exist. What the SSDLC is telling us, and realistically, as a security practitioner, manager, professional, whatever you want to call yourself, this is the SDLC we should know. It's the SDLC where security is integrated into all aspects or all phases of security. So let's take a look at this. Let's go through these phases again, but what I'm going to be talking about is security. What are you doing in terms of security? Now, I did mention to you guys, I did get this out of the Sean Harris book. So if you have the Sean Harris study guide, then you know what I'm talking about. If not, follow along with me. Okay, Zach says, when we look at the steps highlighted here, the component steps remain the same regardless process. Yeah, when it comes to the SDLC really follows the waterfall method. Agile, we're going to have to cover that in another video. I got to get a good diagram for that. If you guys know I do project management, Agile is a big thing for me. When it comes to, they're going to separate it out. I do have a question on Agile, by the way, tonight. They will separate it out. They're just going to call it SDLC. So, Zach, best thing to stick with it the way it is. So let's take a look. Requirements gathering. So let's go with this phase. What are we doing in terms of security here? In terms of security, you want to, of course, gather all the security requirements. You want to do a risk assessment or a privacy assessment. So here's what this is. Let's say we're making that accounting software. What would be some of the security requirements? Well, does it need encryption? Does it need multi-factor authentication? Where will the data be stored? Can the data be stored in certain countries? Now we're going to go into the risk and privacy assessment. Is it going to be storing PII information, such as PII, personally identifiable info? Is it going to be storing social security numbers or credit card information? Well, if it's an accounting application, it probably is, because we have all those employees' social security numbers. We have customers' credit card information. So the privacy assessment is saying, well, how much real secret data is this thing going to be storing? So now you're gathering all of this information. In the designing aspect, now you're going to design the software to meet these particular, again, I'm just concentrating on security, guys. That's what we're concerned about. Obviously, you're going to design it for its functional aspects, right? That's part of it. But when it comes to security, we're going to be designing it for those security requirements. So does it need encryption? Well, does it need 256-bit encryption? What type of encryption is it going to use? Is it going to use just plain out TLS to do all this transport? Do we need encryption in the database or in the hard drive? Like, does the servers need to be running TPM chip, for example, that stores the actual data? Believe it or not, our school database, that's a requirement on us that it's hard drive based encryption too. So we have to start designing to meet all of these security requirements. Now, in this phase, you're going to be thinking about the attack surface and threat modeling or threat analysis. Here's what this is. The more features and functions and codes that your application have, the more likely it's going to be attacked. The bigger the attack surface. When you make software like Windows, which has a giant GUI on it, and it does a bunch of different things, all that means is there's more to attack. The more code, period. The more code, the bigger the attack surface. The more code, the more likely you're going to get hacked. So we have to do the attack surface, to analyze this attack surface and see what we can reduce. And it's best to design this in. A threat model. What are the threats the software is going to face? Worms, different types of viruses, ransomware, internal threats such as employee trying to steal the data. You think about this for a second. Wouldn't it be amazing if software is designed from the ground up to meet security requirements. The problem in today's world is we are adding security later. What we're doing is we are basically designing the software, coding, installing it, and then when a security risk arises, then we're patching it. You guys got to remember something about modern day security. And you know, you saw this in the beginning of your study guide in this section anyhow. The problem with modern day security software development is software is being released because they have this thing called time to market. In other words, you got to be the first one out. And there's really not much security aspect going into it. Then when a security vulnerability is found or the software is hacked, what happens? They release a patch, right? You see this wall behind me? This wall don't need a patch because there's no hole in it. You got to remember something. When you patch something, you're fixing a hole. That means the product was given to you with a hole in it. So the next time you guys push out a patch to a software, be it Windows or your accounting application, just remember, you're patching holes that was given to you. Wouldn't it be amazing if the software maker had thought about what threats they could have faced, had looked at the entire attack surface and say, okay, so this is where we could be attacked. Here's what code could be vulnerable. Wouldn't that be amazing if they had fixed and plugged all of the problems and designed the software with security in mind? Wouldn't that be amazing? From a security aspect, that would be amazing. But then this, let's be realistic. It's probably not going to happen because it'll just increase the development time. But anyhow, we'll keep that for discussion for another day. The next thing we're going to do is we're going to code the software. Now, static analysis. Coding the software, I'm assuming you guys know what that is. Literally, programmers sitting in front of a computer, typing code. A couple of things I do want to mention when they code the software. A term you may or may not see on your exam that you should know, something called case tools. Case tools stands for computer-aided software engineering. Now, case tools is what programmers use really to write software. Whether that's pushing out, whether that's getting blocks of codes and helping them write the codes quicker. Basically, the ability to quote-unquote copy-paste codes. Case tools is just a series of tools that will help software developers write the codes quicker and make the code writing more efficient. So know that term does exist. Now, static analysis. When the software is being coded, you got to know this term, right? If anybody in here has ever taken this exam before, you'll know there's a term that shows up quite often, is static analysis. Static analysis is done when the software is being coded, it has not been run. It's a test against the actual code. So if you're testing the code, you're reviewing the code for vulnerabilities, problems, errors, and so on, that's considered static analysis. Now, I do want to point out that some practice questions, and your exam too, will differentiate between what is considered static analysis and code review. What is the difference? Well, people say it sounds, or it's basically the same thing. Static analysis is more of a computer automated program that reviews the codes for you. That would be considered static analysis. Code review is a manual inspection by humans. So in that sense, code review can detect more vulnerabilities and problems than potentially static analysis. But it is a manual process and it will take an incredible amount of time. For example, let's say a bad programmer writes a backdoor in the application, but programs it, but writes it in a really good programming method that it meets all programming standards. The static analysis would read the code and find no issues because the static analysis really doesn't really realize, is that a feature or is that a hack? But when a manual coder reads it, a human read it, the human will be like, yeah, that's a backdoor. What the hell is this doing here? And take it out. So sometimes you might see the differentiation, and there is a differentiation between code review and static analysis. The next thing up is testing. Now, testing. Term here, obviously the software is done. It's been compiled. Software is working. We got the full physical software. We got to test the software, right? Testing the software is going to be doing things like dynamic testing. Now, dynamic testing generally means running the software in runtime. The software is actually running. A lot of the tests that we carry out are generally some form of dynamic tests. So the software works. It works well. They're going to be testing like boundary analysis. They're going to be seeing, okay, then can this field hold this much of data? One particular test that I've seen showed up quite a few times, something called fuzzing or fuzzers. What is it? What is a fuzzer? A fuzzer is a piece of software that injects random data or unexpected data into an application to see how it performs. You think about this. Look at a database. Look at a giant application. What if you go into every field and you just mash the keyboard and start just pushing random data into it? What happens? Does it crash? Does nothing happen? Does it get corrupted? Does it freeze on you and come back? What happens? Oh, that's the idea with a fuzzer. You're trying to see what happens. Unit testing is testing each individual unit. Integration testing is when you bring the units together to make sure that the modules work well together. For example, if you develop them in modules, accounts payable and receivable, when you bring the entire software together, does it all play nice with each other? User acceptance testing is also done here. So almost all the testing that doesn't relate to code review or manually looking at code is done in the testing. Now it goes into release and installation. There's really not much here. Basically, the software is finished making. It goes out. You're going to be doing a final review that was all the security requirements met. And as people is using it, in this one here, if there's any vulnerabilities found, you're going to be doing patches. You're going to be doing updates to the actual software as time moves on. Now, disposal. Now the software is done, right? So let's say 5 years goes by. The organization doesn't want to use the software anymore. Now, what do? Well, there's really two paths here. Either they completely decommission the software and throw everything out and just archive the data, or they upgrade the entire system to a brand new system. This position for your exam, and particularly for the CISSP, I'm going to talk about data sanitization. Now, where did I get this phase from? People say to me, hey, Andrew, where'd you got that phase from? I don't really see that in any of the books. You know, if there's one thing that I have learned when teaching CISSP over the last 700 years is you're going to learn about NIST and CISSP. CISSP it pulls a lot from NIST documentation. Now, this particular, the SDLC that was mentioned in this documentation, this particular publication, I'll give you guys a link to it. Maybe something you just want to glance by quickly. It was depreciated in 2019, but there is a phase here I do want to talk about. And you'll notice that they have a phase. What is the SDLC phases? Initiating. Remember I said sometimes people include that to get the project authorized. Developing, implementing, operating it. So we got these, right? Developing it, or acquiring, implementing it. But notice they have a phase called disposal. So what is this? Well, in this this is the final phase. All right, this is the closeout of anything that we're going to be building. What are we going to include? Well, do we have a disposal or a transition plan? So this is what I was telling you guys about. Do we have a plan in place for when the software is no longer needed? What are we going to do with it? The main thing I want you guys to remember is sanitization of media. Now, I can't get into this in just a small live stream here. But sanitization of the media, what they're talking about, if you guys remember, like degaussing the media, destroying the media, that type of thing, you should have studied that in Domain 2. Disposal of the hardware and software that is used in that section of the, that is used in that particular software that you were using. So that's the main thing they talked about here. All right, build and execute a transition plan so we can get rid of it. You know, when you're studying for your CISSP, I don't think you guys need to go and memorize or read all of this, all of these NIST documents, but it was worth mentioning. In fact, the Wikipedia article did talk about disposal, or Wikipedia calls it the end of life. All right. So that is my presentation on the SDLC. Let me ask you guys a question, get you guys some feedback. Did you guys learn something tonight? Does anybody have any questions? How long that took? 20 minutes? 15 minutes. You know, one of the things when you're studying the CISSP is you want to go somewhat in depth, but you don't want to go too far in depth, right? You don't want to study like you're rewriting, like you're making a whole new SDLC. You want to just understand a good high level overview of it. You want to understand what you're doing in it, and always look from the security aspect of it. So hopefully you guys learned a lot from that little presentation there on the SDLC. Okay, very good. We're going to do some practice questions now. So guys, let me ask you guys a question. Did you guys enjoy my presentation tonight? What's wrong with you guys? Nobody's participating tonight? Come on, guys. By the way, did you guys click on the like button? There's not a lot of you guys in this class. I know, CISSP, it's not, I didn't realize that today was a holiday last week. I didn't realize that till the end of last week. So maybe we'll get some more folks that'll join us next week. By the way, if you guys want me to cover a topic next week, put in the box what topic you guys would like for me to cover, what topic you guys are thinking we should cover next week, and then we can cover that also. All right, so with that in mind, guys, let's go ahead and do some practice questions. I got 8 practice questions we're going to be doing. Some of them are about half of them are related to like SDLC topics, and then some of them are not. Zach says, I know a lot of questions are applied, and looking at SDLC, do you know what is the most critical area to understand? You know what, Zach? I wouldn't say there is a very critical area to know. You don't know what your exam gives you. Know the entire thing. Know that the whole thing matters. You see, one of the things we have to remember with the SDLC is, from a security perspective, we can't concentrate on one over the other. You can't spend all your time concentrating on requirements gathering and then forget testing, and then security components are not tested. You can't spend all your time designing the thing, but you never got into gathering the right requirements. Now, one thing I do want to point out is, when you're looking at the SDLC, remember, where should security be implemented in the SDLC? Everywhere, and as early as possible. Anytime you guys get a question on the SDLC on your exam of where security should be, look at the choices and choose the earliest of the 4 choices. Say to yourself, hey, those 4 choices, well, B is the earliest of those 4. That's where security should be. Security is not an afterthought. It's the first thought, right? The moment the manager says, we need a software to do this, your next thing will be like, well, this is how we're going to secure it. Always add security from the start, never the end. So keep that in mind as you study your SDLC. Okay, guys, let's go do some practice questions. Let's knock out some practice questions here, guys. I'm going to put some questions on the screen. They shouldn't be too difficult. We just went through them. Should not be too difficult. All right, so literally I just gave you the answer to this one. The security manager is working with a team to develop a new financial software. What phase of the SDLC should security be added? All right, guys, put the answers in the box. Put the answers in the box. Lewis, how does the maturity model? So, you know what? Keep that question for a minute. I'm going to cover that in a minute. I do have a question on the CMM. I don't have time tonight to cover CMM. Maybe we can do that another night. But the maturity model is just nothing more than, basically it's a certification to show how mature your coding practices are. Man, you guys are giving me big topics, man. You guys said next week we should cover encryption. Yeah, that's like a 4-hour presentation, man. Give me something small, like a topic within a topic. All right, so where should security In what phase should security be added? So we got some D's, we got some A's, we got some D's, we got some A's. All right, so you got to use the tip I just gave you. The tip says, look at this. What is the earliest of these four phases? Is it design, test, installation, or requirements? What is the earliest of these four phases? Well, the earliest of these four phases, if we go back, is requirements. That is the earliest, and this is the first one, making that the best answer. Now, you don't just design things. You have to know what you're designing. Remember what I just mentioned. Security is not the afterthought. It's the first thought. All right? They said they want a piece of software. That's the next thing we say is we're going to go ahead and the next thing we're going to do is we're going to go ahead and add those and get those requirements added in there. All right, so don't forget the tip, guys. A team is conducting static analysis on a software. What phase is the team most likely working on? Development, testing, installation, requirements. And so remembers this from what we just covered. But the answer is in the box. Let me know what you guys got. Static analysis. Static analysis. Now let's see what you guys got. That's right. The answer is A. If you guys remember, developing is where we're doing the static analysis, right? So remember, when they're coding the software is when they're going to test the code. It's as they're coding the software, they can run the static analysis as the software is being coded, like typing the codes. So static analysis would best operate here. Testing, tricky quick thing there. Testing is mostly where you do your dynamic tests, not really your static tests, by the way. Installation, the testing should all be done by then. Requirements gathering has no testing. All right. The organization, management wants to implement a new software, difficulty listing the privacy risks. What phase of the SDLC most likely influence privacy? Requirements, design, developing, or testing. You're talking about privacy. Where are we going to worry about privacy? When we're designing it, when we're gathering those requirements, when you're developing or testing it. All right, put the answers in the box. All right, guys, put the answer. We got some B's. All right, we got some A's. A. All right, lots of A's. Let's see if you guys remembered. So when we're talking about privacy, where do we do a privacy analysis? Like, where would we know what type of privacy or we should really, what type of privacy controls we really need to have? And that's going to come from, if we go back to the diagram, that's going to be from right here, right? That's going to be from requirements gathering. So that's where we would get our privacy from. So the answer here would be requirements. All right, hopefully you guys, okay, almost everybody got it. Okay, good. All right, so you guys can see the SDLC, guys. It's not going to be too difficult for your test, but you just got to know it well. All right, an application tester is provided unexpected and random to an application. I should say, I forgot the word data. Random data to an application. This has led it to crash. What testing is this? Is it user acceptance testing? Is it fuzzing? Is it a DOS attack? Or is it a static test? All right, guys, put the answers in the box. You guys, I'm telling you guys, make sure to review before you go into your exam room. Before you go into the exam room, know your test, know your static test, know your dynamic test, know fuzzing, right? If you're using the official study guide, chapter 15, there's a whole lot of tests that you guys should be familiar with. Zach, is it possible to see questions after addressing the requirements? Is that see questions? Is it possible to see questions addressing requirements that comes after an application has been implemented? I hope not. Zach, that would just be bad security, right? If you're addressing security requirements after the system has been implemented, that sounds like real life. We don't want real life on this exam. This exam is not really based on reality, I should say. This exam is based on the perfect world of security. But, you know, I don't think you're going to get a question like that because there would be you would have to basically redo the thing and reinstall all the software, or remake the software. All right, so a lot of you guys got the answer here as B as basically fuzzing. Yeah, fuzzing, I mentioned earlier, fuzzing is a type of a test where you feed it all types of random data and then see what happens. Does it crash? Does it get corrupted? All right, practice question number 5. Now, I did want to mention this topic since I was covering the SDLC. I did want to mention this topic to you guys. An organization has been CMM certified for the past 2 years and has quantitative performance improvement objective. What would be the next phase? Is it managed, defined, optimized, and quantitatively managed? Let me give you guys a good link here, okay? I see you guys like the part about it not being based. The exam is not based on reality. You know, let me not say that before ISE square kills me. The exam is based on this perfect world of security. The exam is based on this world where security requirements are added from the beginning and policies are made and people actually follow them. It's made and where everybody likes complex passwords. You know, unfortunately, that's not what the world is about. But when you take your exam, that's the world, that's the mindset you got to have. Okay, let me see how many of you guys, I'm going to help you guys out with 2 topics tonight. You guys should know CMM is a hot topic for your exam. It is in the exam. It's called out in the exam objectives. All right? It's called out in the exam objectives, something that you guys should know. Let me see how many of you guys knows the answer. If you don't, let's give it your best shot. Right? Give it your best shot. Make a guess if you don't know it. Now, you really have to memorize those. You really have to memorize those levels. All right, we got some C's. All right, let me see anybody else. Come on, guys, make a guess. Give it your best shot. Somebody said they're taking the test like in a few days. Who said that? One of you guys says Trevor. Okay, Trevor said taking the test. Trevor, you should get this. Trevor, you should know this, Trevor. Come on, you get your test in 2 days. You should already know your CMMI levels. Okay, guys, the answer here is going to be C, optimizing. Where did I get this from? Let's find out. So let me give you guys a quick lesson on CMMI. You guys can hear my phone in the background. I forgot to shut it off. So CMM, the compatibility maturity model, there is an institute by the ISACA that gives you the certification. I'll give you guys a link here. So you see this one here that says maturity levels. If you scroll down, these are the maturity levels that you guys should know for your exam. All right. These are the basically there's basically five of them. And initial, manage, define, quantitatively manage, and optimize. And you're probably wondering, what the hell is this about? And if you ever seen this for the first time, you're like, what is that? This is really a certification. It's a certification that tells you when you're hiring software developers how good their software development methods is. And I'll show you guys where this is used. So I had a company call us up the other day, and this is a company that gives you virtual employees from outsourced employees, and they do like app development and stuff like that. So they were like, oh, we could remake your website for TIA, and we do good job of programming. And I'm like, oh, how do I know you guys are good at programming? And they're like, well, we are, notice it says there, see it says right there, we are CMMI level 3. So what does that mean? Well, organizations would publicize this to say, hey, we are good at developing because they're level 3, they're defined. They have organization-wide standards that provides guidance across projects, programs. So they have a good standard across the entire organizations to do good software development. If you're at a level 1, well, if you're ever certified at a 0, work may or may not get done. If you're certified at 1 initial, work gets completed, but it gets delayed. So this is not good to do. You don't want to hire a company that's a level 1, right? Level 2, well, projects are planned, performed, and measured. At a level 3, which you're probably going to get most companies coming in at, the company has good standards across the entire business. So it's not like an ad hoc development, like that guy makes it this way and that guy does it this way. By the time they get to level 4, which is quantitatively managed, it's data-driven with quantitative performance objectives. So quantitative means numerical analysis of the data. After this is level 5, the main one for your exam is going to be continuous improvement. So in level 5, it's going to be, okay, not only are they gathering data, numerically speaking, on how they're developing and how successful they are, but they're also going to be improving their processes. Continuous improvement is a big thing. So that's level 5. Before going into your exam, guys, please memorize your levels. Watch, I'll give you guys a quick tip. IMDQO. I manage Daphne, Quinn, and Oscar. It's the best one I can come up with. All right, I manage Daphne, Quinn, and Oscar. That's the best one I can come up with. I would like for you guys to memorize all of this. Make sure you know it well. By the way, don't complain about memorizing for CISSP. It is CISSP. It is a very big exam. All right, hopefully you guys learned something there in that one. That was a bonus topic for tonight. All right, here we go, guys. A security manager has noticed an internal customer list has been exposed on the internet from an internal database connected to a web application that was secured with TLS. What attack most likely led to this? Injection, DDoS, SynFlutter, man in the middle. Now this is typical CISSP questions. You got to really know the topic. You got to know it somewhat well. All right, guys, put the answers in the box. Trevor taking your exam coming up. Who else? I forgot the names. Who else more we got? We got Zach. You're a couple days. Zach next week. All right. EV762. I can't pronounce your name. March 4th for you too. D. Okay, so you guys, let me know what you guys got. Okay, we got a lot of. What do we got? Some A's. Okay, so answer on this one is definitely A. Why? Well, let's talk about this. So, first of all, they stole the data. This is a confidentiality attack. DOS attacks are not known to, doesn't really affect confidentiality. DDoS attacks and DOS attacks makes the service quote unquote unavailable. Anytime for your exam you see a DOS attack, think availability. But it can also cause corruption of the data. This leads to integrity. Most of the time, things like DOS attacks does not expose the data. Very rarely it'll ever do that. Their objective in a DOS attack is to bring the thing offline. So that eliminates that. This will not expose data. In fact, the SYN flood is a type of a DOS attack. A man in the middle. Now, a man in the middle is our glorified sniffers. A man in the middle attack is when you sniff the traffic. Basically, you sit in the middle between two connections. If you have my Security Plus course, you see I show you how to do one with a software called Cain and Abel. The thing with man in the middle is that if the data is encrypted, the man in the middle doesn't see anything. That's why it says in secure with TLS, so that fixes that. Now, an injection attack. It does say from an internal database. Well, what attack affects databases? SQL injections. SQL injection is when you type SQL codes, commands into a database, into an application front end, like a web application, to hit that database in the back end. You can do all types of things, whether it's taking the data out of it or manipulating the data in the database. Basically, it's using SQL commands to manipulate the data, whether that means stealing it, corrupting it, changing it. It's up to you. It depends how the application is programmed. Don't forget for your exam, stopping something like an injection attack generally requires input validation is one way to stop that. All right, I forgot the word layer on C here. All right, let's go. An organization experienced a large number of SYN handshakes on their gateways. This has led to a few web servers going offline. What if the OSI model is happening? Now, I did mention to you guys last week, you guys need to know the attacks of the OSI model. All right, if you're a tech, you know this is pretty easy. Even if you have things like your Network Plus, it shouldn't be too difficult. All right, guys, very good, very good. Put the answers in the box. Okay, so the answer here, I have no idea. One person says EV762. I have no idea. Oh my God. Come on, this is a relatively easy one, Trevor. And Trevor, you're lucky you're not sitting next to me, Trevor. If not, you're gonna be in trouble. Okay, Trevor? Trevor, I'm worried about you, Trevor. You got come on, guys. You guys need to know this. This is not a joke. This is serious stuff. Layer 4 transport. All right. SYN floods. SYN floods. The TCP handshake. Come on, guys. The TCP handshake, SYN, SYNACT, and ACT, that operates, quote-unquote, TCP is a transport layer protocol. So it's at the transport layer. It's not layer 1. That's physical, so that's garbage. It's not layer 3. That is the network layer. Network is IP. Remember, TCP layer 4, IP is at layer 3, so it's not this one. Session layer is not concerned with handshakes at all. Layer 4. Now, half of you guys got this one wrong. I am disappointed in you guys. Not good. Come on, guys. You guys should do better than that. All right. An organization is building a new application wants security to be integrated throughout the SDLC and prefer to be released ASAP. What development method is best? Waterfall, Agile, Security Agile, or Security Waterfall? I'm going to give you guys a hint. Two of these terms are made up. You want it to be released quickly and be more integrated. What are we going to be doing? Jason, if you're thinking of SYN floods and all that, TCP and UDP is covered in Chapter 11 of the official guide. That is correct, Jason. Absolutely. Exact thing to tease. Okay. All right, let's see what you guys know, guys. All right, we got some A's. We got one A. We got some B's. A's and B's. All right. All right. A's and B's. Okay, guys, the answer here is going to be Agile. Hold on, I made a mistake. Hold on, let me fix that. This is what you do for doing it 1 hour before the class starts. Okay, so it is Agile, guys. Agile development allows for quicker releases versus waterfall. Now, waterfall, everything takes very long, right? You got to gather requirements. You got to build the software for an incredible amount of time. You got to test it. Agile pushes software out very fast. Security, Agile, and waterfall, those are made-up terms. Those don't exist. But Agile, so what are you doing? Scrum, extreme programming. Remember, Agile is an umbrella term that includes all the incremental or iterative software development. Making B the correct answer. Okay, guys, very good. I only had 8 questions tonight, guys. Okay, did you guys enjoy the session tonight, guys? Did you guys had some fun in the last 1 hour, guys? Security integrated. Yeah, you know what? Agile allows things to be more customer feedback. The integrated thing there, both of them would have allowed that. That was just the trick part of it. It was the fast releases. Agile pushes releases quicker. Would waterfall be more secure? No, don't say that. Agile is just as good. You know, if you think about Agile and waterfall, at the end of the day, if you create a software in Agile versus waterfall, you probably end up with this same software at the end of the day. It's just that Agile would include more user feedback and be pushed out in increments versus waterfall or traditional methods may take longer but may accomplish the same result. All right, very good. Is Agile more modern than SDLC? Well, SDLC is really related to traditional or waterfall method. Yes, Agile is very popular today. In fact, if you took my PMP class, you saw that. Guys, thank you guys for showing up tonight. I'm glad everybody was able to make it. Guys, if you're on LinkedIn, give me a shout out. Okay, go to LinkedIn, type my name. I had a pretty interesting post this morning. If you're on, join me on LinkedIn. There was a post I put this morning that I had I thought it was pretty hilarious. Somebody slammed the hell out of me. Join me on LinkedIn. You'll see what I mean. Give me a shout out on LinkedIn. By the way, on Reddit, sometimes, you know, when I'm coming up with a lot, I always put it on Reddit. If you guys pass your exam, if you guys, you know, enjoy my content, always mention me. Let's get more people involved. The more people come, guys, the more questions we got. That got certified by Andrew. Yeah, I should have one of those, right? I should start selling some merchandise on YouTube. I don't think I have enough subscribers, though. But did you guys click the subscribe button? Did you guys do that? You know, Dan, that's a good question. What are the drawbacks of Agile? You know, I can't really, you know, think of, you know, I wrote the best-selling PMP study guide, and I covered Agile extensively. in it. And Agile just has so much benefits that there really isn't much drawbacks to it. If you think about it this way, Agile pushes things in increments. It gets more customer feedback. Um, Customers see more value up front. Traditional, they don't. Traditional takes forever to build something. In Agile methods, they can get a release done they have what's called sprints, right? A sprint is about 1 to 4 weeks worth of work. A release can be just a few of those sprints. If you start a software project and use an Agile, you can have a release within a few months. If you do waterfall methods, it may take a few years to get the full software. The only drawback I would see with Agile is sometimes Agile can't work. Sometimes Agile can't work for every project. Not everything could be released in increments, but there are Agile methods of where you can develop them in iterations. So that would be something. Send me a LinkedIn invite. Never stop adding features. Nothing ever gets finished. That is true. When does the Agile project end? Because there's technically the product backlog never actually runs out of features. But, the Agile project should have a set time and budget, what is known as inverting the triangle. So EV762, technically it should come to an end at some point. And it's maybe not compatible with all projects. But it is a hot topic in today's world, not for your exam so much, but it is a really hot topic in today's world for the simple fact because it allows software to get quicker. But, we got to ask ourselves, Zach, EV762, Zach says scope creep is worse. Is an application ever finished building? Think about this. If you customize an application, is it ever finished, technically speaking? No. If you think about that, this world is never finished. This world evolves every day. The world changes every single day. Organization changes, methods change, people change, processes change, products change. And for those reasons, the whole ecosystem of applications changes on a daily basis. Agile methods works because when you build the application to a certain point, you may build it again, and then you build it again. This topic gets into the whole topic of DevOps. Maybe we can cover that another week. All right, we're just branching into stuff here. Guys, thank you guys for showing up. I'll see you guys next week. I'm thinking how does cryptography sound? Would you guys like to learn some cryptography next week? How about if we do a quick presentation on the difference between, somebody said, I can't do the whole cryptography. We're going to go nuts. Symmetric versus asymmetric. Talk about some algorithms and hashing. Would you guys like to do that? A quick lesson on cryptography. How does that sound? Symmetric, asymmetric, hashing. What do you need to know for your exam? And how is it implemented? It's the PFP problem. Joshua, I used to teach Microsoft. I used to teach Cisco. I've helped thousands of people pass Microsoft exams, MCSE. Yeah. They get a series. I don't know, man. I'm just trying to answer people's questions. What I did this live stream for was to do practice questions with people and answer questions. All right. Something more conceptual. That would be something. What about PKI? Lewis, maybe we could do that the following week. PKI is a big topic. I try to keep these sessions to like an hour. All right, try to keep them to an hour. The big thing I want to do with you guys is the practice questions. Guys, I'm out of here, guys. If you guys want to take a live class, join Technical Institute of America. Don't go spend thousands of dollars. We're $1,500 actually. If you guys like this, hey, join our live classes. If not, come on here and let's talk. Let's learn some things together. If you guys are in different, what do you call, Discord, I think, Reddit, whatever. Hey, give my name a shout out I greatly appreciate it. Thank you guys. You guys have a good day. Have a good week. Have a good evening. Good luck on your exam. And I'll see you guys in a week. All right, guys. Take it easy, guys.